Hi, scientists. Welcome back to our study of matter. And in this lesson, we're going to talk about atoms and elements. Now, never trust an atom, they make up everything. So, what is matter made of? I believe we've all heard that matter is made up of atoms. But can you imagine how difficult it was for early scientists to try to prove something that they couldn't see? Here are some of the scientists whose theories have been part of the atomic theory of matter. The theory that matter is made up of tiny particles that can't be divided was first proposed by a Greek philosopher, Democritus, in 400 BC. The particles Democritus proposed were too small to be seen. Aristotle, a Greek philosopher who lived after Democritus, believed that matter was not made of particles. This theory was widely accepted for 2,000 years. However, neither of these theories was based on experimental evidence. And you can imagine they didn't have the technology that we have today. It wasn't until the early 1800s that Dalton began to measure chemical reactions. And the measurements made it possible for John Dalton, an English chemist, to propose an atomic theory of matter that was based on experimental evidence. Dalton's atomic theory is that all matter is made of tiny particles called atoms. So he's given credit for the term atoms that we use today. What did Thomson propose? Well, the atom, he believed, was composed of electrons surrounded by a soup of positive charge, somewhat like negatively charged plums in a positively charged pudding. So his theory is often referred to as the plum pudding model. Rutherford, a New Zealand born physicist, discovered that the interior of one gold atom is mostly space and that the center is tiny and dense and solid. Rutherford believed that an atom is like a small planetary system with protons in the center, like the sun, and surrounded by electrons, like planets. In 1913, Niels Bohr proposed a model of the structure of an atom. In his model, electrons circle the nucleus at fixed distances from it. The paths in which the electrons move are called orbits. They are also referred to as energy levels because their distance from the nucleus depends on the energy of the electrons in them. Low energy electrons orbit close to the nucleus, while higher energy electrons would orbit farther away. What was Chadwick known for? He studied beryllium atoms, which led to the discovery of neutrons. But our current modern day theory and model of the atom shows a blue haze of orbitals instead of circular orbits. And these orbitals are areas where electrons are likely to be found. So, for your listening enjoyment, click on Robert E. Wells' book, What's Smaller Than a Pygmy Shrew? So, the structure and parts of an atom, most of our fifth graders have heard about protons, neutrons, and electrons. Did you know that about 5 million atoms could line up across the period at the end of a sentence? That's how small they are. And the particles that make up an atom, again, are protons with a positive charge, neutrons with a neutral charge or no charge, and electrons that move about around the nucleus, which are negatively charged. So go ahead and click on this great video with Page and Dexter, who teach us about the atom. In a little more detail, remember the atomic model theories changed over time. Okay, we still refer to and often sketch Bohr's model with these orbits. So the nucleus is the center of the atom where protons with a positive charge with a mass 2,000 times that of the electrons is found. So, in the nucleus with these positively charged protons are neutral charged neutrons. Okay, they have no charge, but they're present with the protons in the nucleus. And surrounding the nucleus are electrons. And we're going to learn later, they're just kind of anxious to escape sometimes and combine with other atoms to form compounds. And it's this attraction between the negative and positive charges that holds an atom together. All right, ready to sing along with the Addams Family? Here's the lyrics to their song, so go ahead and click on the video and sing along with the Addams Family. What's a molecule? We often hear the word atom and molecule. Well, molecules are two or more atoms linked together. And oftentimes, atoms don't exist alone. They like to partner up. So the atoms of some elements do not occur alone. Some are linked together, two or more, to create what we call molecules. So when atoms are linked together with only atoms of the same kind, they're in a pure state, such as these oxygen atoms. So we have two oxygen atoms, and you can see how they're sharing these outer electrons. So they link up together to form a molecule. So you can go ahead and click on this picture for a very short video on how molecules form. All right, we understand atoms. So what are elements? An element is a substance that is made up of only one kind of atom. I bet you can name several different elements. A very common and well-known element is gold. So if one atom is taken from the element of gold, it is still gold. It still has all the properties of gold. Some other common elements just to talk about in our next lesson will be the periodic table, where we discuss elements in even more detail. But oxygen, we're breathing it in now, is a colorless gas that makes up 20% of the atmosphere. And it is the most common element in the Earth's crust. This pilot is breathing oxygen through his mask. How about sodium? Sodium is a silver colored metal and is soft at room temperature, but actually can become brittle as the temperature decreases. If you've ever driven down a street and looked up at street lights like these, sodium vapor in this light glows when electricity passes through it. How about silicon? It's a dark non-metal solid, and it's the second most common element in the Earth's crust. Electric circuits are printed on thin pieces of silicon. How about chlorine? It's a greenish yellow gas with a sharp odor. It is 2.5 times as dense as air. So if you remember back to Miss Hummel's lesson on density, you'll know that chlorine gases then will kind of sink to the floor because they're more dense than air. And our bleach solutions contain parts of chlorine. So let's wrap up a little bit with discussing what an element may look like when it's put on the periodic table. Um, And each element has an atomic number. The atomic number is the number of protons that are in one atom of that element. We're going to discover that there's more than 100 elements on the periodic table. Okay? Um, in a pure form, most elements are solids at room temperature. A few elements, such as oxygen, nitrogen, and helium, are gases. And we're going to find that only mercury and bromine are liquids. What else can we be looking for when we're identifying elements? Every element has a chemical symbol, and that's an abbreviation that sometimes is based on the Latin words for our elements. So, for instance, gold, the Latin word begins with AU. So that's why its chemical symbol is AU rather than maybe G or GO. Another number that we'll often see related to elements is an atomic mass, which is approximately equal to the number of protons and neutrons in an atom. So, ladies and gentlemen, this was our introductory lesson to atoms and elements, and I look forward to seeing you back soon.